Hello, welcome to Guidancee Education Channel. In this video, we are continuing Class 12 Physics, Chapter 1, Charges and Electric Fields. Under that, we are discussing dipole in external electric field. I have already posted a video on torque experienced by an electric dipole resting in uniform external electric field. If you have not watched it, click the I button in order to watch it. In this video, we are going to discuss a few important problems which always appear in exams as well as in competitive exams. Do not skip problems that will affect your performance in the exam. So, this video will definitely help you. So, watch the video completely without skipping, and if you think the video is useful, like the video, share the video with your friends, and also leave your comments or doubts in the comment box below. Subscribe my channel and also press the bell button so that you get intimated as soon as videos are posted. Also, see the description box where I give details. Come, let us see the problems. Go through the given picture and find the magnitude and direction of net force and torque on the electric dipole in external uniform electric field. 5 pictures are given here. You have to find out the magnitude and direction of the net force and torque. I have already posted a video on torque experienced by an electric dipole resting in uniform electric field. If you have not watched that video, click the I button in order to watch that. We are using the same principles here. Okay, we will take up one by one. This is the direction of electric field. Negative Q, positive Q. So, direction of dipole moment is from negative to positive. Uniform electric field means the direction and magnitude of electric field is the same. This point is applicable for all the 5 diagrams that are given here. Force on negative Q due to electric field will be equal to negative EQ. I will note it here. Okay. Force on positive Q is equal to EQ. Acting in the same direction of dipole moment, the negative EQ acts in the opposite direction. Net force will be equal to the sum of these two, that is EQ plus minus EQ. What will be the value? That will be equal to 0. Magnitude of EQ and negative EQ are the same because Q has the same value. So, the total becomes 0. This is true for all the 5 cases given. So, the answer for that section is the net force on the dipole is 0. Now, torque. Torque is equal to PE sin theta. Theta, the angle between electric field and dipole moment, is 0. Sin 0 is equal to 0. Therefore, torque becomes equal to 0. Now, the second diagram, net force is equal to 0, torque is equal to PE sin theta. Theta is equal to 180 degrees because the electric field direction and dipole moment direction are anti-parallel. Look at the position of plus Q and minus Q. Sin 180 degrees is equal to 0. The alignment in the first case is theta is equal to 0 degrees. It is called stable alignment. In this case, the electric field direction and dipole moment direction are parallel. They are in the same direction. In the second case, dipole moment and electric field are in opposite direction. They are anti-parallel. The second case is called unstable alignment. You may be asked to depict the diagram showing the stable and unstable alignment of the electric dipole in uniform electric field for the examination. So, you can give these 2 diagrams. Now, the third diagram. Here, it is resting at an angle theta. I will mark the direction of P. Net force is 0. Torque is equal to PE sin theta. This gives the magnitude, but what is the direction? This will turn in the anti-clockwise direction to align itself with the electric field direction. So, the torque will be directed, projecting from the plane of paper. Now, let us pass on to the fourth. Dipole moment and electric field directions are mutually perpendicular. So, it is resting at an angle 90 degree. Force is equal to 0. Torque is equal to PE sin theta, that is PE sin 90 degrees. Sin 90 is equal to 1. So the value is torque is equal to PE. Maximum torque is experienced when the dipole moment is perpendicular to electric field. Dipole will rotate in the anti-clockwise direction. So direction of torque is the same as in the previous case. That is, project outward from the plane of paper. Okay, let us move on to the fifth question. The direction of the electric field is reversed. It is in the downward direction. Dipole is resting at an angle with the electric field. The net force will be 0, but there is a torque and the dipole rotates in the clockwise direction. Torque will be equal to PE sin theta. Direction of torque will be into the plane of paper. I hope it is quite clear. Many children find this topic, that is electric dipole resting in external electric field, very difficult. But once you get the concept clear, then the topic becomes very easy and interesting. Move on to the next clipping where we do one more problem. An electric dipole with dipole moment 4 into 10 raised to minus 9 coulomb meter is aligned at an angle 30 degrees with the direction of uniform electric field of magnitude 5 into 10 raised to 4 Newton per coulomb. Calculate the magnitude and direction of the torque experienced by the dipole. Write the dimension formula of torque. Okay. Torque is equal to PE sin theta. We will first write up the data that fetches you some mark. P is equal to 4 into 10 raised to minus 9 coulomb meter. E is equal to 5 into 10 raised to 4 Newton per coulomb. Theta is equal to 30 degrees. So substituting we get torque is equal to 4 into 10 raised to minus 9 into 5 into 10 raised to 4 into sin theta. Sin 30 degrees is equal to 0.5. So 20 into 10 raised to minus 5 into 0.5 will be equal to 10 into 10 raised to minus 5, which is equal to 1 into 10 raised to minus 4. What is the unit? This coulomb and this coulomb will get cancelled. So what remains is Newton and meter. So it becomes Newton meter. Torque is equal to 10 raised to minus 4 Newton meter. Okay. Direction P and E. If P and E are represented on the plane of the paper, then the torque may be directed into the plane of paper or outside the plane of paper depending upon the direction of P and E. Now the dimension formula of torque. We will do that from the unit of torque. Dimension of force is equal to M L T raised to minus 2. For meter, 1 more L. When we put these two together, we get the dimensional formula for torque. It is equal to M L raised to 2 T raised to minus 2. I hope it was quite clear. We will meet in the next video with another important topic like this. Till then, bye. Thank you.